In this video, we're going to wrap up the examples of finding antiderivatives, finding the integral. We've looked at finding the indefinite integral, for example, if it's just the integral of f of x dx. In part 3, we're going to look at the integral of f of x dx on the interval from a to b. That's called a definite integral. Okay, so evaluating the definite integral. This is called the fundamental theorem of calculus, part 1, and we know that the integral from a to b of f of x dx is capital F of b minus capital F of a, where lowercase f is equal to the derivative of capital F. So we're going to look at two examples of how we could evaluate an integral, a definite integral by hand. So here we have the integral from 1 to 5 of 2x dx. By the fundamental theorem of calculus, we know that that integral should be equal to f of 5 minus f of 1. So we need to find f of x, the antiderivative. All right, integrating 2x dx, we're going to get x squared plus c. We can conclude the following. F of x is x squared plus c. F of 5 is 5 squared plus c. F of 1 is 1 squared plus c. And evaluating the integral, we do f of 5 minus f of 1. All right, so you can see that the c values are going to be subtracted from one another. All right. So in the next example, we're going to look at the fact where we're not going to find the indefinite integral with that plus c. We're going to get to ignore it because in the end, those c's will drop out. All right, so here's example 2. Evaluate the integral from 0 to 5 pi 6th of cosine of x dx by hand. Okay, so let's integrate cosine of x, and we get the sine of x. We're going to evaluate from 0 to 5 pi 6th. This is the notation that you can use, this bar with the lower and upper limits of your integrand. All right, and we're going to evaluate. This is really f of 5 pi 6th minus f of 0. All right, we've not used the plus c because we know those c's are going to drop out. And so we're just going to get 1/2 minus 0, or 1/2. Okay, so just some practice evaluating definite integrals. I'll do a few of these and then leave the rest of them for you. So here we go, the integral of x cubed dx from 0 to 1. Integrating x cubed, we get 1/4 x to the 4th power, evaluated from 0 to 1. So we're going to look at 1/4, 1 to the 4th, minus 1/4, 0 to the 4th. Okay, so we get 1/4 minus 0, or 1/4. Okay, let's look at number 7. The integral of e to the x is e to the x. We're going to evaluate that from 0 to 1. So that's e to the 1 minus e to the 0. That's e minus 1. All right, how about number 8? Now number 8, I want to think of that algebraically, that absolute value. I could think of it both algebraically and graphically. Okay, so remember the absolute value graph. Has a slope of -1 on the left and +1 on the right, and we're looking at that integral from -2 to +1. Okay, so thinking about it geometrically, we know what areas we're going to be adding up. We should probably also think about the understanding of rewriting this as the integral from -2 to 0 of negative x dx plus the integral from 0 to 1 of x dx. Okay, so we're going to get -1/2 x squared evaluated from -2 to 0 plus 1/2 x squared evaluated from 0 to 1. Okay, first integral, first antiderivative, -1/2 x squared evaluated from -2 to 0 would be 0 minus a -2. So that's +2. I'm going to check that again. I know 0 in there would be 0. -2 squared is 4. That's -4 over 2, which is a -2, but I'm subtracting it. Remember, it's f of b minus f of a. So that's the first antiderivative evaluated from -2 to 0. The second one will be 1/2 minus 0. So in the end, I'm going to get 2 minus 1/2 or 3/2. Okay, I'm going to let you do these other problems that I have not looked at. Let's take a look at a few problems on this 10-minute workout. These look to be all simple antiderivatives, indefinite integrals, so no evaluation is going to take place. Just looking at these, I'm going to let you do these as well, but the only thing I would say is see if you need to rewrite anything. Okay, so for example, the square root of x, maybe write that as x to the 1/2. Okay, 2 over x I'm going to leave. X to the 3/2 I will leave. All right, so think about if you need to rewrite anything. In question 2, I would leave the 3 over x, but I'm going to rewrite 2x to the -2 before I integrate. Okay, number 4, I'm not quite sure how to do cosine squared of x or 1 over cosine squared of x, so think of your trig identity here. What's another name for 1 over cosine? That would be secant. So this is secant squared of x dx. Okay, going to look at the last 4 questions. X plus 1 squared, we should probably distribute and expand this product before we take our derivative. X squared plus 2x plus 1. So then take the derivative, the integral. Okay, number 8, x plus 1 over x, break up your fraction. Into 1 plus 1 over x, and then take the integral. Okay, number 9 is pretty straightforward. You got the integral of cosine, the integral of sine. Number 10, you'll have to think about that one. That's got a little extra foreshadowing happening here, thinking about what's going to come up later. Okay, I'm going to let you solve the rest of those antiderivatives, and assignment 2 you should be able to complete based on the videos for finding antiderivatives algebraically.